Next example, though, yes?
-4 or -4? Because you put -4.
It's positive 4. Sorry about that. So in the next example, we're doing the same thing. We have our two functions right now, but now we're taking g of x over f of x. OK? So we look at this and we say, all right, that's going to be x minus 4 all over f of x, which is x squared plus 4. So now, again, now we have this new function on the denominator. However, if you guys think about this, are we really concerned about our domain restrictions in the denominator? Look at what the domain is of that. All real numbers, right? And so therefore, again, so that's the domain of all real numbers, but can it equal 0? And if we look at this, if we set this equal to 0, because the difference here is we don't want it to equal 0. Even though the domain is all real numbers, we don't want it to equal 0. Well, in this example, we don't have to worry, because if we're trying to take the square root of a negative number, that's going to be in the imaginary numbers, right? And think about this. Any number that you plug in for x, are you ever going to get to 0, at least in the real number system? No, right? But be careful, because what if I gave you the problem and it looked like this? Now is it possible to plug a number in for x and get it to be 0? Yeah, 2 and -2, right? So just because the domain is all real numbers, you still have to be careful with that constraint in the denominator, which I didn't do for whatever reason. But anyways, so the domain here, we don't need to worry about the domain being 0 in the denominator, because that's true. It's never going to equal 0. However, we have our constraint here in the numerator, so the domain is going to be from 4 to infinity.